Chapter 5, Lesson 37 is going to be, again, graphing rational functions, except now this time we're going to have oblique asymptotes, meaning, from what you learned a couple of sections ago, that the numerator degree is going to be greater than the denominator degree. So just to kind of show you again what those asymptotes look like, vertical obviously goes straight up and down, horizontal goes straight across. Now our oblique is going to go on an angle. Now we're just going to deal with numerator degrees that are one bigger than the denominator. So if the degree of the numerator is 4, the degree of the denominator will be 3. It could be 2 or 1. It could be more than a difference of 1, but we're only going to deal with ones so that they'll be lines. It is possible to have an oblique asymptote that is not a line. That would be something that you would cover in another class. All right, so let's start off. So x squared plus 3x plus 2 divided by x. So this one's going to end up having an oblique asymptote because the degree of your numerator is 2, and the degree of your denominator would be 1, if I make that x to the first. So we will end up with an oblique. We're going to do all of the pieces the same way as we did before. So we're going to take the numerator. First of all, we're going to factor this because it's not factored for you. We're going to take the numerator, set it equal to 0 for our x-intercept, take the x's, set those equal to 0 for our y-intercept, find our vertical asymptotes, setting the denominator equal to 0. There won't be any holes in here because you're not going to end up having any matches, and then we'll fill in the oblique asymptote. So here's what each one of those pieces will be. So if I factor the numerator, it'll be x plus 2, x plus 1. Denominator will just stay x. So x-intercept is taking the two pieces of the numerator, setting those equal to 0, so negative 2 and negative 1. If you plug in 0 for the x's, you're going to get 2 divided by 0, which is undefined, so there will be no y-intercept in this case. That's something new. We haven't seen that before, but it is a possibility. Vertical asymptote, take the denominator, set it equal to 0, so you'd have x is equal to 0. You won't have any holes because these two things don't match. And then for oblique asymptotes, like you learned in the first section in this chapter, to find the oblique asymptote, you do long division. And so when I divide, again, after you divide and you get a remainder, that remainder doesn't matter. So it's just, in this case, y is equal to x plus 3. So I'm going to take each one of these pieces and place them on the graph. So here's what this would look like. So here are my two x-intercepts. Here is my vertical asymptote at x is equal to 0. And the oblique asymptote, I graphed the line y is equal to x plus 3. So this would be the line y is equal to x plus 3. If we had a scale on this for the y's, that would be there at 3. Okay. However you want to go about graphing your lines, me personally, I would just find what the x and the y-intercept are for that line, plug 0 in for x, solve for y, plug 0 in for y, solve for x. With this one here, when you do that, you get negative 3 on that one. And when you plug 0 in for the x, so then you would take those 2 points. So your negative 3 for your x, your positive 3 for your y, and connect it. That's how I would do it. Okay, so then that's all of our pieces. Now to graph this, drag some of this stuff out of the way here. All right, so we have two x-intercepts, both of which, when we had this, were to the, when we looked at this here, those were both to the first power. So that means it's going to cross through those. The thing that you want to look at is your vertical asymptote right here. You're going to have graph that goes to the left of that, and you're going to have graph that goes to the right of that. Okay, so I'm going to start with the x-intercepts over here, remembering there is no y-intercept in this case. I have to cross through both of those points, and I have to run along these asymptotes. So the way that that would work, it would look like this. Come through the two, somewhere it would turn around, go through the 1, and run along that asymptote there. Okay? So that's what would happen to the left of the graph, or to the left of the asymptote, excuse me. To the right of the asymptote, I know my graph can't be anywhere in here because I don't have any x-intercepts, and this asymptote here is from x to the first. So from what we've learned, it has to come from the opposite direction. So because this one goes down, this one will have to come here from up. And so I would come down, run along the asymptote, change direction somewhere in there. Where? You could plug in points if you wanted to, but I'm not asking you to do that. Change direction, come along, and then run along the oblique asymptote there. So as a little bit better of a picture, that is what your graph would look like. All right, let's do another one. X squared plus 2x minus 3 over x plus 4. So maybe you want to take a minute and pause the video and find what the factoring of the numerator would be, figure out what your x-intercepts will be, what your y-intercept will be, vertical asymptotes, do you have a hole in this case? And then this one will have an oblique asymptote because this is squared and this is to the first. All right. So there's the factoring. X-intercept, 2 of them at -3 and at +1. Y-intercept, when you plug in zeros for your x's here, you'll have -3/4. So 0, -3/4. This does not match with anything at the top, so it's a vertical asymptote at x equals -4. Nothing matches top to bottom, so no holes. And if you do your long division, you will end up with x minus 2. So your oblique asymptote would be at y is equal to x minus 2. So just like the previous problem, I'm going to place all of those pieces. So here's my vertical asymptote, here's my 2 x-intercepts, my y-intercept there at -3/4, and then the oblique asymptote. And again, if you plug 0 in for x, you'll get -2, so that would be that. If you plug in 0 for the y, you'll get +2, so that would be that. There's the connection for the line. Okay, so this time we have 3 points in the middle here. So again, we're taking our vertical asymptote, looking to the right of that and looking to the left of that. So because these are both to the first power from the exponents on it, it's going to go through. It's not going to bounce at either one of those points. So the only way to get through all 3 of those points would be to start up here, come through, change directions, go through, and run along the asymptote. Okay, so that would be the right-hand side of the graph. That would cover everything from this vertical asymptote over to the right. From this vertical asymptote over to the left, then, because this is x plus 4 to the first, and I go up here, that means I need to come from the opposite direction, so that means I would come from down here, change directions, go along the asymptote. Okay? So, again, there's a little bit better picture of what that would look like. All right, so that is lesson 37. Let me know if you have any questions.